An operation is a function performed on numbers such as addition, subtraction, multiplication, division, squaring, etc. For simple equations, the order may not matter. However, calculating the operations in the wrong order for complex expressions can cause very different answers. For example, 3 plus 5 times 7 seems relatively simple at first. 3 plus 5 is 8 times 7 equals 56. But what if the operations were in a different order? 5 times 7 is 35, and 3 plus 35 equals 38. We calculated two very different answers for the same problem simply because we didn't follow the same order of operations. The term order of operations defines a technique that standardizes the way in which arithmetic operations are accomplished. The rules for order of operations are as follows. Do operations within parentheses first. Next, resolve any exponents. Then multiply or divide from left to right. Finally, add or subtract from left to right. For problems concerning order of operations, remember that the fraction bar can be used to indicate a division sign. The fraction line should be treated like a parenthesis for both the numerator and the denominator. Let's practice. Here's a rather complex arithmetic expression. The first step in solving this sequence is to accomplish operations within parentheses first. 5 times 3 is equal to 15, so the expression is reduced as follows. Next, resolve the exponent. 2 raised to the second power is equal to 4. Then, accomplish any multiplication or division starting at the left and working to the right. The first operation involving multiplication or division is 7 times 2, which is 14. Continuing to the right, the next operation involving multiplication or division is 4 divided by 2, which is 2. The final step is to accomplish any addition or subtraction starting from left to right. 14 plus 15 is 29, and 29 minus 2 is 27. The final answer to the original expression is 27. Let's work an example. In electrical circuits, the current can be found by using the equation I equals V divided by R, where I is the current, V is the voltage, and R is the resistance. In this simple circuit, the resistance is found by adding all the resistors in series. Since 3 of the resistors are the same value, we can multiply 3 times that value and add this to the remaining resistor values to find the total resistance. To determine the final value for the current, we substitute the values for voltage and resistance and apply the appropriate order of operations. First, accomplish any operations in parentheses first. There are no operations in the numerator, but there are several operations in the denominator. Within the parentheses, resolve any exponents. There are none here. Next, accomplish multiplication and division from left to right. 3 times 5 yields 15. Then, accomplish addition and subtraction from left to right. 15 plus 15 plus 20 equals 50. Finally, simplify the answer. The total current in the circuit is equal to 2.